Good morning everyone, my name is Sonia and here I am going to represent my thesis work which entitled Handwritten Punjabi Character Recognition Using Convolutional Neural Networks, which is a deep learning technique. The handwritten recognition, it is the process by which the computer is able to understand and interpret what the handwritten text is. So we are using deep learning techniques here for its implementation, and we are using the Punjabi script. The dataset I have collected it from 20 users that consists of some XML files which contains the stropwise information for a Punjabi word. It contains the information like how many strokes are used to write a single Punjabi word and in which temporal order it is using and their corresponding XY trajectories. So using this stropwise information, I have extracted this information word-wise in an Excel file, and using this information, I have converted them into their respective Punjabi character images, which is further used to train and test our model. So, CNN is preferred because in simple neural networks, the neurons in one layer have connected to its previous layer neurons in a fully connected manner that computes the global features from the handwritten text. Whereas in CNN, we are using the activation window, which we are shown here. This filter size window is convolved around the handwritten input image one by one, shifting each time with its stride value so that we are able to compute the local features from the handwritten text. And number of filters are used in one convolutional layer. We are seeing here, so that if one filter is not able to extract some features from the handwritten text, then another filter at the same position can extract that feature. So we are computing the results obtained from these number of filters and then getting the next activation map window for the next layer, so that more and more deeper features we can compute. Thus, these CNN layers are X as in feature extractor and fully connected layer X as in classifier to classify our handwritten images. So this is the convolutional layer example which we are, as we discussed before, and the max pooling we are using to extract to provide the local spectrality to our process. We are picking the most relevant feature. For example, here 8 is the highest value. We are picking this highest pixel value to recognize later on. And after max pooling, our spatial dimension of the images decreases. So the extra image pixel values are padded as 0. So we need not to maintain the overhead of the size of the pixel matrix. And the fully connected layer is used at the end. The features computed from the convolutional layers, it use that features and classify into one of the number of classes available. Next, there were previous some approaches used elastic matching, in that they compute the Euclidean distance between the test samples and the training sample prototypes, and the minimum one will be the resultant one. But here it is more efficient for the user-dependent data. Next, the hidden Markov model was used that depends upon the statistical probability values, so higher mathematical computations needed, so training time was higher. Next, the zone density approach was used, in which we segmented our image into different zones, and the SVM classifier is used for each separate zone, and the features are computed from these respective zones. If any outlier is present, then it will not be very efficient way to recognize our characters. Next, this Tversky gives this deep learning concept of CNN for the face recognition of human faces, and we give they achieve a very high results, and from here we can get idea that we can use also this approach for our research. Then we have to segment our characters first into their individual characters. So I am using the horizontal and profiling techniques for that purpose. And the CNN approach is used for the previously for other scripts like Devanagari, English, Telugu, and Odia, and it achieves a very good recognition results. And the amnesty database is also being implemented using CNN, and we are achieving very good results. So the main objective of this thesis is to use this deep learning technique to recognize our Punjabi characters, and more convolutional layers we are using, more and more deeper features we are able to compute. And we are using the TensorFlow library, which is provided by Google for the first time to recognize our Punjabi characters. And the problem was as different users have their own style of writing, and also for the same user, there will be a variation in writing due to the speed of writing or due to the mood and something. So it will create a problem to achieve the high recognition results. Also very there are a number of characters which are similar in shape that creates a problem. So these are the hardware software requirements used for the implementation of CNN using TensorFlow. And before training the model, we use some pre-processing techniques to normalize our images for the centering of store and to interpolate the missing points to smoothing out of curve. We are using VisiCurve implementation. Now, the TensorFlow, how it actually works, we are computing the dot product between the input pixel matrix and the weight values and applying some activation function value to normalize the output results. And by comparing with the actual values, we compute the post or the array function, and then we are sending it to optimizer. And using back propagation technique, we are updating the values of our weights and bias to update the values so that we achieve the higher recognition results. I have used 5 convolutional layers and 2 fully connected layers. These are the different parameters. Uh, I have used 32 feature maps in first convolutional layer and a subsampling layer to compute the local features. The output of first is given to the second convolutional layer, and I have achieved this. And 16 feature maps are used in second convolutional layer, 32 in third, 64 in fourth, and similarly 84 feature maps are used in the fifth convolutional layer. And after computing the features from these convolutional layers, we provided it as input to the fully connected layer that use these features to classify our images into the classes. So at the end, we achieve a vector array of size equivalent to the number of classes available that contains the probability, and the class containing the highest probability will be the resulting class. So we can use CNN in various. This is the result I have achieved. I have used these 3 different ratios of our data set to compute the training, testing, and validation accuracy, and the higher result obtained for training is 99.04, for testing 98.07, and for validation 93.05. And these are some misclassified classes which is classified by our model. And we can use it in various applications like for signature verification, writer recognition, bank check processing, or any healthcare industries. And for research perspective, we are using Google or TensorFlow library for the first time for the recognition of our Punjabi script. It provides many inbuilt functions to train and test our model. So we don't have to start from the scratch. We can use these functions and can focus on our data set to improve the accuracy results. And the best way is we can use the TensorFlow for the distributed environment also. I'm using it only for the single CPU processing for now. So in future we can extend this process and we can add the Punjabi numerals dataset to our dataset to make it alphanumeric dataset. And depending upon the dataset size, I can use the distributed environment using CUDA GPUs libraries for and then can compare those results with my results in future also. And I have submitted this paper to the Neurocomputing and Applications, which is a Sprinter journal, in the end of June 2017, and it is still in review process. And for any questions and queries, you can contact me at soniamittal883@gmail.com. Thank you.